Hey, Truthloaders! I am Michael Stevens from the YouTube channel Vsauce, and I am a person. As far as I know, you are a person as well. There are a lot of people on Earth. In fact, there are more people on Earth right now than there have ever been on Earth alive ever in all of history. The human population is growing exponentially, and exponentially doesn't just mean fast, it means crazy fast really quickly. 100 years ago, there were fewer than 2 billion people on Earth. Today, there are 7 billion. At that rate, within the next 100 years, the population could be 16 billion. Exponential growth also means, and this is a serious calculation, that if nothing were to slow us down, by the year 6000, Earth would be nothing but a pile of human flesh expanding outward at the speed of light. So, clearly, something needs to slow this down, and something will. The Global Footprint Network has estimated that given all the people alive on Earth today, we need about 1.5 Earth's worth of resources. Problem is, we only have one Earth. So we either need more planets, better technology, or fewer people. Well, today, with Truthloader and a panel of experts, we will ask the question, how many people can really live on Earth?
Hello and welcome to the Truthloader special. It is here, we've been talking about it for a while, and we're joined by Michael Stevens of Vsauce.
Hello everybody. Phil, I'm excited. We're live and we're going to learn.
We're going to learn. We have an amazing collection of guests with us today. You can see them all at the bottom of our screen. And we're going to try and figure out how many people can live on Earth. Now,
exactly.
Your introduction, we are currently using 1.5 planets according to the Global Footprint
That's what
Network.
we need.
Yes.
We only have one though.
We only have one.
Yeah, that's a little unfortunate. But I'm I'm optimistic about what we'll be able to do with technology, maybe moving to other planets, but actually the panelists that we have here today, the guests, know more.
Indeed they do. So we might as well introduce our first guest. We're going to go in order today because all of our guests are brilliant. So we have a video that introduced our first guest. He's called Nick Nuttall. So without further ado, let's play the tape.
A former journalist, Nick joined the UNEP in 2001 and has been responsible for transforming the organisation's media profile. He spearheaded crucial landmark reports, including the economics of ecosystems and biodiversity, which states that we are only now seeing the real value of nature and the services it provides. The report recognised that with a population thought to hit over 9 billion by 2050, we had better get smart in managing nature. Otherwise, we will run out of the natural resources and services that make life possible in the first place.
So, hello, Nick.
Hello.
How are you?
I'm fine. I'm here in Kenya, in Nairobi, where the United Nations Environment Programme is headquartered globally.
Excellent. So, Nick, I'd like to kickstart this with a question that's probably on the lips of everybody. Is there a maximum number of people that environmentalists think the planet could possibly support?
Well, sadly, guys, I don't think anybody's got an answer to that question, right? But the question is, can we actually support a lot more than we have right now? So currently, humanity in the last, 100 years or so has been actually carrying out an extraordinary mining operation of planet Earth. We are running everything down that basically supports life on Earth and the livelihoods of currently 7 billion people. The question is, can we get smart about it? And actually, if you look around the world, there are loads of really extraordinary stories happening in communities and countries across the world where they are decoupling resource use from economic growth. The question is, how can we accelerate? How can we catalyze? How can we actually scale up the extraordinary activities of many, many communities and countries across the world? You take an example like Germany, like last year, their rooftop solar generated half the country's electricity, right? Now, you talk to some of those Daily Telegraph readers down in the south of England, and they'll tell you, oh, renewable energy is a waste of time, huge amounts of money spent on it. Why do we spend like $800 billion on fossil fuel subsidies and only $80 billion on renewable subsidies? We have a skewed world, we have bizarre economics, and basically that's undermining our opportunities to live together in harmony with 9 billion, 10 billion, 11 billion people, whatever the number is.
Do you have a question you might want to ask Michael?
Yeah, so you seem optimistic about some solutions, Nick, for how to increase the amount of resources that we have for people. But the first thing I want to ask is what is the current rate and idea of how many people we will have in the future? Over the next, say, 25 years, within the lifetimes of all of us.
Well, people talk, people talk about 2050. They talk over 9 billion in 2050. Actually, the rate of population growth is slowing down right now. I mean, I can't predict the future. I have no tea leaves with me, but the best estimates are somewhere over 9 billion by 2050. Is that too many? Well, you know, I mean, we are, look, at least a third of all the world's food, as we know, is being lost or wasted. Now, that's just simply stupid, isn't it? Why are we losing and wasting a third of the food? Food is going to be the center of the future of this planet. Let's get smart. Let's stop wasting food, right? Let's stop losing food, right? Then we can start talking about feeding the planet, right? If you talk about greenhouse gas emissions, well, you know, we have all the technologies, we have all the policies out there to basically reduce the buildup of rubbish into the atmosphere that's triggering a global temperature rise. So why don't we do it, right? Because human beings are very short term. We need to take some long-term visions. We need to get smart at what we're doing. I think it's infinitely possible we can go to much larger numbers. I'm sorry if that's kind of boring debate, but that's how I would see it myself.
No, this is fascinating. I have one other quick question. You mentioned that the growth of our population has decreased lately. I remember hearing that it was highest at, what, 1960?
The growth rate has, please correct me if I'm wrong, Nick, but the growth rate has actually come down since the 60s. Is that correct?
It's the rates are coming down right now. You know, we had this big spike. You mentioned the numbers before. Why is it coming down? Lots of reasons. You know, in some cases it's smaller families. In other places, you've got the issue of some countries like China that took a one-child policy. Lots of reasons. So the rate is going down. But don't get me wrong. Hey, don't get me wrong. On every single indicator, bar almost just a handful, we did a survey as the UN Environment Programme last year on 90 key environmental indicators. Fish stocks, climate change, whatever. Only on 4 is the world making progress. On all the others, we're making zero progress, or we are making very poor progress, right? So all the best efforts of humanity to manage this planet in a sustainable, smart, intelligent way, all the indicators show we are absolutely screwing up big time, right? The question is, can we change that around? Yes, we can, but we have very little time.
I have a question here. Maybe you read this out, Michael, and honor this comment. It's from Mad Cow 11200.
Yeah, so this is a good question. Mad Cow 11200 says, what about building underwater? I know the pressure would be an issue, but assuming future technology and materials can resist this, would it be possible or beneficial? Most of our Earth's surface is covered in water.
Yes.
Not potable water, but water. Can we start using that land, or can we start better using the water that we do have in the ocean?
Look, I mean, you know, people love to have these technological solutions. The fact is that nature itself has solved all the problems that we would ever need to solve if only we get smart about looking at nature. A lot of people talk about climate change, and they talk about fitting huge capture storage systems on the tops of power stations to actually take the carbon off, right? This is because there's a small number of companies that could actually benefit from that. The fact is, forests for millennia have been capturing carbon. Why don't we just increase our forest cover? And you get tons of benefits that go with that as well. You know, there's lots of very in-your-face, very obvious solutions to all our problems if only we stopped looking after the minority who want to make a big profit out of this planet and started dealing with the majority and caring about the interests of the maximum number of people rather than the minority interests that basically want to carry out the mining operation of this planet.
So one final question before we move on to our next guest, and it's a good segue really because we're talking about water, and that's what our next guest will be talking about. But what's standing in our way, Nick? Because there seems to be a pretty massive consensus that we should do something. Everybody seems to be well on board with that. And yet, as you said, none of this stuff seems to be happening. What's standing in our way?
Well, let me just correct you there. I think a lot's happening right now. I mean, I think there's a lot going on the planet, but basically it's not enough. It's not at the scale or the acceleration that we need. And we need to actually recognize that a lot of the economics, a lot of the things that we value on this planet that are really worth things, are actually not brought into the broad economics of how we operate. I live in Kenya, right? There's a major forest here which produces all the water for the Masai Mara, all the infrastructure of tourism. It produces the moisture for the exporting tea industry. It's been trashed for many years. You put on the table what the services of that forest is worth, $1.5 billion to the Kenyan economy, and now Kenya is restoring this forest and is getting donors in from all over the place because suddenly they realize that the natural services of nature, which keep this world operating, actually have an extraordinary economic value in terms of trillions of dollars, and we've never factored it into this rather boring thing called GDP, which is what drives the ups and downs of the global economy.
Nick, thank you very much. We're going to move on to our next guest. His name is Jay Familietti. We have a video to play to introduce this guy. If while you're watching this you have any comments or questions or things you'd like to read out, do get them in. So let's take a look at that video.
For many years I've been working with a satellite called Grace.
Jay Famietti is a professor of Earth System Science and of Civil and Environmental Engineering at the University of California. He is the founding director of the UC Center for Hydraulic Modeling and worked with a satellite called Grace, which measures groundwater depletion. He was also featured in the documentary Last Call at the Oasis, which is about the fact that the global water crisis will be the central issue regarding our world this century. He is primarily concerned with water conservation and campaigns to raise awareness about water usage amongst policymakers and the public.
So, Jay, hello.
Hi, thanks for having me, guys.
Yeah, no trouble. I'm glad to have you here. So, Jay, I first saw you in the film, which I've only seen half of for the moment, but it was an incredible film, The Last Call at the Oasis. Maybe you could explain to our viewers why is water shortage such a huge problem?
Well, let me give you a really water-centric response to that. As humans, really, water is everything to us. It lies at the heart of all that's important. We heard from Nick talking about food. It's also important for energy production. Of course, it's a critical issue in economic security, international security, climate security, and so on. So it's always been important to us, and it always will be important to us. Some of our work, you mentioned the movie, some of our work is looking at how the distribution of water on the planet is changing, and I think that situation that it's going to create is a situation really of haves and have-nots, which will, I think, really challenge water management of the future.
So how much water do we use right now, for each person perhaps?
Well, so that's an excellent question because the standards vary incredibly widely. So I'm talking to you from California here in the United States, and we use a tremendous amount of water in the U.S., probably about 100 gallons per day. And if you look around the world, the standards vary widely. When you go to the water-stressed regions of the world, they may be using and have access to 10 or more times less.
So, Jay, before we went live, before anyone was watching, I think it was you who quoted Keats, the poet,
No, that wasn't
about
me.
water.
No.
Now, who was it?
I think that was Nick. You wouldn't find me quoting Keats. Maybe
It
he'll
wasn't
listen.
Keats
no.
anyway. It's
Well,
W.H.
could you
W.H.
remind
Auden. W.H. Auden.
Could you tell the audience this quote? Because it kind of blew my mind. I had never thought of it this way before.
It was W.H. Auden who got famous for most contemporary people from 4 Weddings and a Funeral. And the quote was, many people have lived without love, but none without water.
Many people have lived without love, but none without water.
Right.
Yeah,
So
scary. We need it.
so that's
Jay, go ahead. Sorry, Jay.
so that's a pretty profound quote, and it's something that's been with us for a long time. There's this famous quote. I'm not sure who said it. It might have been John Wayne. It might have been some other cowboy in the Western United States, and it was something like "Whiskey's for drinking and water's for fighting." So quotes like that have been around for a long time. I once took a ride with a taxi driver who said, "Hey, if I run out of gas in my taxi, no big deal. I can always go to the gas station and get some more. But if I run out of water, I die."
So how much water do you use, Michael, per day? Come on.
I've never even measured it. In fact, I think that if we forced people to keep tabs on how much water they were using, somehow their homes would calculate it for them, like display it right below every clock in the house, it might blow your mind how much you use. And it would also probably blow your mind to see how little changes you made would make that number so much smaller or bigger. I think there's a lot of lack of awareness, especially in like the countries that we live in, where we just use water because it's like basically free, available anywhere at any time. Not only water, but clean, drinkable water.
Which we have right in front of us. We
literally, I have a whole cup of it right here just for me. And I didn't even ask for this.
It's just the right.
So I do
Jay,
too. I have a cup too.
You mentioned, sorry, I have a question. Jay, you mentioned that in America people use 150 gallons per day, per person. How can we visualize that? What kind of thing might that fit inside so we can visualize it?
Well, that's a good question. I don't know if we could get 100 gallons inside a refrigerator. And we have big refrigerators in the United States, so it's it's pretty big. But you know, Michael, I think you raised a really good point about we don't really tend to. Good job. We don't tend to think about our water use, and in part it's because in many of the developed parts of the world we're pretty spoiled, and so we have fresh water delivered to us. It's clean, it's cold, it's great. Look, there's Steve having a drink of water. And so we kind of take it for granted, but there are so many things that we can do in the house. Appropriate landscaping outside of the house, efficient fixtures inside of the house. Of course, things like shorter showers and baths are all, fixing leaky pipes, are all things that collectively make a huge difference. And following up on something that Nick was saying earlier, just before me, we can do a lot more with a lot less all around the world.
Okay, so Jay, here's my question.
Well, I just want to say, I mean, you know, what's so extraordinary is that the actual water infrastructure of this planet, it comes in many ways, right? It comes through the forests who capture the moisture in the air and then put it in the ground and then release it into river systems. But why would it be that humanity has drained something like half the world's wetlands, which are just natural water storage systems, right? I mean, if you look at the massive floods that occurred on the Yangtze River in 1998, which displaced lots of people, what the Chinese did was they reforested in the mountains. They basically restored all the wetlands down the river system of the Yangtze, and now they've got a functioning river system again. So when it floods, the flood water goes into the wetlands, and they use the wetlands now for fisheries, and they use the wetlands for actually purifying water, right? Because wetlands also work as sewage disposal systems. So in the West, what we do is we build big machines, right, to purify water. And now increasingly in the developing countries, they're getting back to the old system of understanding that wetlands provide fish, provide water storage, and purify shit, right? So actually, that's what we need to get back to, are these kinds of concepts that basically change the dynamics.
I agree with you.
Right, using nature.
Yeah, I agree with you. I agree with you very much, Nick. I think part of the reason we've evolved into or devolved into the situation that we face today globally, there's a couple. One is in the name of economic growth and development. And the flip side of that is that the ecosystem services that for example, wetlands and floodplains provide, or the environment in general, is ridiculously undervalued. And that's why we find ourselves globally in the position that we're in today. One thing that I like to say when I give lectures, give lots of lectures all over the world, especially over the past couple of years. And one thing that I think it's important for the developing world to think about is to learn from the mistakes that in particular environmental mistakes that the developed world have made. We've made many mistakes, and when places like China and Africa they are accelerating their development. India. There's a lot of missteps that have been made in the developed world that don't have to be made, and still tremendous progress and tremendous growth that can be realized.
Jay, thanks very much. I think we have one real quick question that we saw here from a guy about baths and showers. Maybe quickly ask that.
Yeah. Actually, when I saw this question, I figured I knew the answer, but then I doubted myself, so I'm sure you guys know better than me. What uses more water, a typical bath or a typical shower?
So let me answer that. Can I answer that one, because I've actually written on that.
Yes.
And if you're me, a shower takes takes more because I'm a daydreamer. And so I'll go in the shower and I'll crank up the hot water and I'll stay there for half an hour. But I think most people, but maybe I'm atypical, and I think most people believe the statistics show that showers actually use less.
Right, so like a 5, maybe 10-minute shower is still going to use less water than a full bath.
That's right.
So
interesting.
There's the message, guys. Start taking showers, stop taking baths, as many people in Australia do, as far as I'm aware, because they have a huge problem.
And don't forget the old saying, save water, shower together.
Yes. You heard it here first, guys. So let's move on to our next guest. I don't need to introduce him because we have a video that will do so. Again, if you have questions, do get them in and we'll get them read out. It's Stephen Mould. Let's play the video.
Steve Mould.
Steve Mould!
Steve Mould.
The one, the only, Steve Mould!
Come on, mate!
Steve Mould is clever at maths. He's a science presenter who has a knack for turning complicated scientific ideas into something that anyone can understand. He's a regular on British TV screens and has appeared on shows such as Britain's Brightest, Blue Peter and The One Show. There's nothing the guy can't do with numbers, and he's done loads of work with the Numberphile team. As part of our show today, we've set Steve some maths challenges to do with population growth.
I was hoping that'd be a bit more spectacular. But...
All right, hello, Stephen. I am a huge fan of your work, by the way. We got to meet a little bit earlier. I have a question for you about laws, mathematical laws. I love anything that ends with the word law, including... Have you ever heard of Cole's Law?
I haven't.
Coleslaw. It's finely sliced cabbage with mayonnaise.
We wanted a joke. We wanted a joke, and we finally got one.
That's why I'm paid the big bucks as the comedian. But I'm serious. Stephen, thank you for joining us. I wanted to ask you about Benford's Law and what that tells us about population growth.
That's a great question. Benford's Law... Well, Benford's Law doesn't actually tell us a huge amount about the problems of population and population growth, but Benford's Law is an interesting quirk of the way we use numbers, and population statistics are a good way of looking at Benford's Law. So it's a fun thing, we might as well have a look at it. So if you look at the populations of all the countries in the world, and you'll find a huge long table. At the very bottom, you'll find countries with tens of people, and at the very top, you'll have 1 billion or so. And so you've got a huge range of numbers. And what if you were to look at the leading digit of all of those numbers? So the very first digit of each of those population numbers. So, for example, if I said a country had a population of 762,000, the leading digit is a 7. And so I might say to you, how many possible leading digits are there? Do you want to have a stab at how many possible leading digits there are?
I guess there's 9.
There are 9, exactly. There are 9 possible leading digits. A number can start with a 1, 2, 3, 4, 5, 6, 7, 8, or 9. And you might imagine that each of those starting digits are equally likely. So if I pick a country at random, it should be equally likely to start with a 4 as it is to start with an 8, as it is to start with a 1. There should be a 1 in 9 chance of a number picked at random from that table of populations starting with 1, 2, 3, 4, 5, 6, 7, 8, or 9. Does that make sense? That's pretty intuitive, right?
It seems like common sense, yeah, but it's wrong, I'm guessing.
It is absolutely wrong. If you pick a number at random from that table of populations, about a third of the time, it will start with a 1. And it will hardly ever start with a 9, and there's kind of a sliding scale between those numbers. And it's something very strange about the way we use numbers. It means that 1s appear as leading digits far more often. And it is actually a useful thing in politics because you can use Benford's Law to detect fraud and things like that. So if you look at an election and you look at you count the votes, you might expect there to be an equal distribution of 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s, and 9s, but there isn't. And that means if someone's making up numbers and they're not keeping Benford's Law in mind, they will make up numbers that don't fit Benford's Law. So you can find out whether an election is fraudulent. You can find out whether someone's cheating on their tax return. Benford's Law is an amazing thing and it works brilliantly well on population statistics. It doesn't tell us a huge amount about population growth and what to do about it, though.
I have a more simple question, I hope. It's how many people could we literally fit on Earth, do you think?
Oh yeah, so I got this question. If everyone was standing kind of shoulder to shoulder, back to back, front to front, whatever.
Really tight crowd.
That's a wonderful example. Absolutely, that's exactly how I imagine it. I worked out.
Acting.
You guys, more feeling. Come on. Yeah, I worked out it was something like 3 billion people could fit standing shoulder to shoulder, back to back, and this actually informs
3 million billion.
3 million billion, around roughly, and this informs quite well on Mad Cow's question, because the point is we're not physically running out of space to put people. We don't have to go under the sea, and even if we were physically running out of space, we just build taller skyscrapers. The real limiting factor is how much land mass each of us individually need, because we eat, right? We eat food, and food needs to grow somewhere. And the question then becomes a lot more complicated. How much physical land mass do we need for all the food we consume? That changes all the time. And historically, that's a very interesting question, because if you look through history, we've always worried about reaching a population cap. You know, even the ancient Greeks worried about, they thought we were going to reach some sort of natural limit, and that's when we had a tenth of the population that we do now, or whatever. And if you look at a recent example, you know, it did look like we were going to run out of space to grow food, but then the Haber process came along. Fritz Haber invented a way to pull nitrogen out of the air and put it into fertilizer, and suddenly our crop yields grew, and the population of the world could carry on growing, you know, unbound, it seemed. The real limit, though, is the energy we use, not the food that we eat, because the energy we use at the moment comes mainly from burning hydrocarbons, right, that have sort of built up over millions of years, and we're just racing through that. If we had to start using land mass to create that energy, we would be really screwed. You know, we need a huge amount of land mass. So we need another technological breakthrough to keep going through once we run out of hydrocarbons.
Boulder Veer on YouTube, I'd just like to say, is very keen to point out that the thing you're describing is an ecological footprint, which was what we described at the beginning of the show.
Yes.
With the global
Yeah. I think, Stephen, you bring up something that just blows my mind. I love putting things into perspective and imagining not only how many people could fit on the land of Earth, but just everyone alive right now. I covered this in an episode once about jumping all at once and maybe knocking Earth off its orbit. Not possible, by the way. But if everyone who's alive right now stood shoulder to shoulder, packed in a tight crowd, you could fit every living human into Los Angeles. Just that little city. It's incredible because it seems so small, but yet, well, as you said, the resources required for us to live are so much bigger than that. We need so much more land and energy than that illustrates.
That's right, absolutely.
So, thank you, Stephen. We're going to move on to our next guest, but do hang around because we've got so many comments coming in. It's incredible, and we'll get some of those read out. But our next guest is, unfortunately, not with us today.
Yes.
He was very keen to be on the show. We were very keen to have him on the show, and he was so keen that he said he'd do a pre-recorded interview with us. His name is Dr. Aubrey de Grey. He's from the SENS Research Foundation, and he believes that perhaps we could live until we're 1,000 years old. So let's take a look at the tape, and then myself and Vsauce and you guys on YouTube and all our guests can perhaps have a little discussion about the implications of the work of Dr. Aubrey de Grey.
The approach that SENS Research Foundation and other groups now are taking to developing medicines that will postpone the ill health of old age is essentially a regenerative medicine approach, not just slowing down the clock of aging, the accumulation of molecular and cellular damage in the body as a result of being alive, but actually repairing that damage, so bringing people back to a biologically younger age than where they were. This has the potential to postpone the ill health of old age much more dramatically than anything that merely slows down aging, because it can be applied repeatedly over time. We have to remember that this will happen gradually. First of all, we're still at least a couple of decades away from developing medicines that really bring aging under proper control. But secondly, we have to remember that even when that happens, the changes that will occur to the demography of the planet, for example, are actually going to happen only very slowly. We'll only be getting older at 1 year per year. You know, there won't be any 200-year-old people for at least another 100 years, whatever happens. Let's suppose that these therapies did come along 25 years from now. These therapies would be able to take people who are, let's say, 30 today, so let's say 65 at the time the therapies arrive, and actually rejuvenate them so that they're biologically 30 again, and they stay there however long they live. And furthermore, this means that there just won't be any people around who are in ill health as a result of having been born a long time ago. That is the most profound impact that there will be on society. People of the sort that you described, people who are in their 20s or 30s now, will not, in 25 years, be spending their time looking after their parents who are in their 80s or 90s and in a decrepit state of health, because their parents are going to be in a good state of health. In fact, they're going to be in just as good a state of health as they or their children are. The systems which exist today that have been built to forecast the trajectory of global and regional population by the United Nations and many other organizations are actually incapable of looking at the scenario in which aging essentially goes away. 20 or 30 years ago, that sort of scenario was just science fiction. But now, even if maybe some people do not think it's a likely scenario, it's certainly likely enough, it's mainstream enough, that it's important that these systems should be able to look at it as one alternative future that we may see in the relatively near term, in the next few decades.
So it's incredible research that Aubrey the Great is doing, but there's a point in there that absolutely blows my mind each time I hear it. Aubrey says that the work he's doing could be available in 25 years, and it will be a therapy that you can repeatedly take which could reverse your body clock until you become aged 30 or so again, and you can remain in that state until you so wish.
That's incredible. I do always find it convenient that these predictions happen to fall within the lifetimes of most of the people making them. But I think it's a little frightening to think of this. First of all, would you even want to live to that long? Stuck in your 30s for 1,000 years?
Mm. But the strange strange thing is about that is we already do this. We already keep people alive as long as possible. So if I got to age 50 and I began to have an ill health and I went to see the doctor and he says, we can actually reverse your body clock until you're 30 again, I think there's a very high likelihood that I'd say, yes, I'll have that. And I guess then I'm on medication. At what point do I decide to come off that medication and say I've given in with life? It's a very strange future scenario we could be heading into. Yeah.
Right, and when you make that decision, are you euthanizing yourself?
Yes.
By deciding to age like most everybody, actually everybody, has always had to do.
Yeah, and we already have these laws in place which actually sometimes, in some examples, have stopped people from taking, forced people to take meds. We don't want them to come off medication because it means they will die because of euthanasia laws. So I guess you would be euthanizing yourself if you came off these pieces of medicine.
Yeah.
These are all really
guys, you know what's so boring? What's so boring about this is that, you know, you might die and actually come back as somebody even more sexy and handsome next time round, and you'd be forgoing that opportunity by, you know, living trapped in your 30-year-old current body.
I'm sure if we've got the medication to reverse your aging to 30, you could also just make yourself a sexier 30-year-old, right? I mean, I'm sure the
yeah. Jolly good.
It is a scary thought, though. If you're 30, so this is Steve speaking. If you are 30 forever, when would you want to, you know, end it all? There's no. I can't picture a time when I'd be sat there thinking, yeah, now is probably a good time. I'm sure I'd be doing something interesting. You know, if you're 30, you're always going to be doing something interesting.
But it might depend on the wife, right? Was she taking the same medicine or not?
Yeah, I think I would have to say personally, I would rather people say, man, I miss Michael, I wish he hadn't have passed away, instead of, are you kidding me, Michael's still alive?
He's still making Vsauce videos?
Yeah. He's still making videos? Come on.
Yeah. So we asked Aubrey the question because I was interested in what his response would be. It felt like that these kinds of medicines were going to have a profound impact on how many people are going to be on Earth. Surely it would. And so we asked Aubrey the question, how many people does he actually think Earth can support?
Fantastic,
This
yeah.
is what he said.
The key thing to remember about the question of how many people could be on the planet is that there is no one fixed answer. Today, we can say that we are pretty much at the limit of how many people we can have on the planet. That's why we're having such a bad impact on the environment. But that's with the technology that's available today. I think it's extremely likely that 100 years from now, or even 50 years from now, technological advances in reducing our use of fossil fuels, and for that matter in carbon sequestration and other things, will allow us to have at least twice as many people on the planet as we have today, with less environmental impact than we have today.
So perhaps 15 million people with less environmental impact.
Perhaps. Perhaps.
That's the prediction we've been given. But we should move on to our final guest. I'd say thank you to Aubrey at this point if he is watching. Thanks very much for that interview, Aubrey. Great to catch up with you. Our final guest is, well, a lot of people are very excited to talk to Jack Fresco. If you're not sure who Jack Fresco is, do not despair, because we have a video to explain the work that Jack has done throughout most of his life. So let's take a look.
My name is Jack Fresco. I'm project director of the Venus Project in Venus, Florida.
Jacques Fresco has dedicated his life to designing the future. His background includes industrial design and social engineering, and he has worked both as a designer in fields ranging from biomedical innovations to totally integrated social systems. His life work is summed up in the Venus Project, which integrates science and technology into a comprehensive plan for a new society based on our human and environmental concern. What makes a man spend the present thinking about the future? Well, Jacques says his direction was set living through the 1929 Great Depression, which helped shape his social conscience. He realized that whilst the Earth was still the same place and its resources were still there, people couldn't buy the products. Jacques decided the rules of the game were outmoded and damaging, and thus began his lifelong work culminating in the Venus Project.
So, Jack, hello, and thank you very much for joining us today.
It's a privilege. Thank you.
Thanks very much for joining us. So, Jack, I'd like to ask, do you think we're currently doing a good job of supporting 7 or more billion people on the planet?
No, we are not doing a good job. We're doing an obsolete job. Most people project a future based upon today's standards. They always ask, how much money will it cost? It isn't the money. Do we have the resources? That's the question. And when money becomes obsolete, that'll be the beginning of a civilized world.
Why do you think it's so important for money to become obsolete in a civilized world, Jack?
Because you can pay off people in the Senate. You can pay more to get a person elected than another person. That's anti-democratic. You can't have a democratic society without purchasing power.
So once if we get over that problem of perhaps self-interest and corruption, what will a system look like that can support 10 billion people, Jack? What physical system will we build?
Well, first I'd like to say to you, people have come over to me and they said, I have 10 children. And I say, what are they for? You have to think about that. Having 10 children doesn't mean anything. Now, I would say the Earth, all support is on the backs of no more than perhaps 200 people that gave us the refrigerator, the lights, the technology to surpass existing standards of living. You cannot discuss this with normal people. They don't have this type of information. So you have to educate people as to the carrying capacity of the Earth. We have to do a survey and find out what the carrying capacity is today and work out a population in accordance with the carrying capacity of the Earth's resources, not the other way around. not how many people will the Earth support. That's a nonsensical statement. How many people can the Earth support? This is what we have to get, statistical data. Now, if you use the scientific method, instead of saying, what's your opinion, what do you think, or use politics, which I find to be very offensive. Social politics
is anyone
nowhere.
currently doing that, using the scientific method to determine answers to these questions? How many people can live on Earth? Is the current system sustainable?
Well, if you want my views on how to end war, poverty, unemployment, you have to do away with the money system. You may not like what I say. You must also do this. You must survey all areas, the water reserves, the facilities, the manufacturing facilities, everything has to be surveyed. And industrial plants have to look alike. They have to be round with extensions sticking out all around with a planning in the middle. And when you do that, you can serve millions of tons of steel and resources. If you don't do that, you're going to have the same problems over and over again.
Now, if we had enough resource and money, how long would it take for the Venus Project to be completed?
Well, does the Venus Project control the media?
Actually, the Venus Project does not depend on whether we have enough money. Jacques advocates a resource-based economy. We have the technology, we have the resources to feed, clothe, house everyone on Earth. We do not have enough money. So we have to go off the idea of money. It's not money that people want, it's access to the necessities of life. And this is what the Venus Project lays out.
So perhaps we could reframe the question. This was actually a question from one of our viewers. Money aside, if we had the drive, the commitment, and we really decided that this was what we were going to do, how long would it take to rebuild the world in the way that Jack has designed over his life? And if anyone is not sure of Jack's work, do check out the venusproject.com and you can see the work that he's done. But how long do you think it would actually take us, Jack, to implement a system like the one you've described?
10 to 15 years. Wouldn't take very long because everything is mass produced. We don't have wooden hammers and nails in buildings like they are today. When the hurricane blew most of the buildings down in South Florida, they put up the same kind of buildings over again. There is no technical authority. We need a technical authority to be able to give us data that we don't have. I don't mean control people. I mean bridge engineers will design bridges, but they don't tell people what to do or how to live. Every person will be assigned a task that they're capable of handling. And you don't need a tremendous population. The whole idea of how many people can the Earth support is ridiculous. How many people can the Earth support? That's the question. And
so is it okay if I chime in, guys?
What's that?
Is it okay if I chime in here, guys?
Yes.
So I just wanted to underscore one of the points that Jack was making about the carrying capacity. I mean, it's such an incredibly important point. You know, we really don't have a sort of holistic view or number that can tell us what is the overall carrying capacity of a region, of a country, or continent, or the world. And we need to be looking over all of water and energy and mineral resources, and we're not doing that. In part, it's because we're lacking the vision, and so we need people like Jack to keep speaking out. But we're also lacking the political will. It's critically important. We're starting to look at the carrying capacity in the water field. How many people can we supply with water? But that field is really in its infancy. We have a lot of work to do. And another thing that Jack mentioned was the exploration. Fully explore a region. And with respect to water, you know, it may surprise you to know that in many parts of the world, we don't actually know how much groundwater we have because the exploration hasn't been done.
Yes.
That's interesting. Jay, I have a question for you about Earth first and then maybe beyond for everybody. My first question is water access to water. Our bodies are mainly water. Our Earth's surface is mainly water. Can't we just desalinate all that water? Can't we just take the water from the oceans? Why is that so difficult?
I should quickly point out this is a question that many people have asked on YouTube.
Yes, good point. Shouts outs to all of you, those of you watching at home, because this is one of your top questions.
Sure. So desalination is certainly an option, but it is one that's very expensive. It's one that is very energy intensive, and it's one that creates a problem with respect to the disposal of the brines, the stuff that's left behind after you remove extract the purified water. You have these very, very saline brines left behind. Many places around the world are already doing it. I've just returned from a trip to the Middle East where it's quite popular, but it's not it's not the best thing to do first. In my opinion, the best things to do first are things like conservation and efficiency. We waste so much water with our agricultural practices. We're extremely inefficient with water. We could do so much more with so much less. Then, after you realize as much as you can from conservation and efficiency and awareness and education, then it may be time for some of these hard infrastructure projects like recycling sewage, which we do in my home county, Orange County, California, and it's quite delicious. And then desal. But that should be a last resort.
I have two questions here from YouTube. They're both for Jack, I think. The first is from Nerdy Shy Guy, who's been commenting a huge amount, so thanks, Nerdy. He says this, Jack, where will the Venus Project be started?
Wherever a nation says it's about time, let's build an experimental city and check out the claims of the Venus Project.
Is there an ideal place to start, Jack?
An ideal place would be in the tropics because there's more radiation of energy there. 2, there's all the energy you want. It's called geothermal. There's enough energy to operate the world at its present rate for thousands of years. Geothermal is self-generating. Solar power, when the clouds obscure the land, you don't get as much power. And wind power, you don't always have the wind, but you always have geothermal energy. There's lots of sources. 2, if you build fish farms in the ocean, several thousand fish farms, they're round and the water can move through it. And then build several thousand on the land, fish farms. Hydroponics, aeroponics. In aeroponics, you spray the roots of the plant with nutrients. There are technical ways. Our problems are not political, they're technical. I've asked a lot of politicians, how can you stop war? Because I don't know, there's always been wars, there'll always be wars. I find that politicians are some of the most ignorant people that I've met.
Unfortunately, within the monetary system, the bottom line is wealth, property, and power. You will not find the solutions to our problems within this system because it holds back finding solutions and working on them. They're not interested. They're really not when there's vested interest that's making a lot of money. They're not interested in the well-being of people or the environment, which has been quite obvious.
Can I just come in a second? I mean, I don't necessarily agree with everything that Jack has said. But, yeah.
One moment. We have a question for Jack from YouTube. Perhaps you could read this out, Michael.
Yeah, so this question is about, okay, well, what about moving beyond Earth, right? We talk a lot about resources available to us on the other terrestrial or extraterrestrial planets.
Yeah.
Is that worth doing, or do we have what we need already here on Earth?
I find that as a bit of science fiction. I don't think we have to move beyond Earth. The Earth is a wonderful place, and we have to take care of it. We have to work on these problems.
What were you going to say?
Nick,
well, I mean, I'm not saying I don't know the Venus Project in great detail, but one thing I would echo is that issue of vested interest, right? which I tried to allude to before. I mean, if you look at the fact that, we had energy-saving light bulbs for donkey's years, but they were hardly ever taken up because basically you had the large light bulb companies who basically didn't want energy-saving light bulbs. Suddenly you've got government policy coming into place saying, actually, because of climate change and other interests, we'll phase out, the old light bulbs, we'll go for the new ones. Suddenly General Electric in America changes its whole factory line to make energy-saving light bulbs, right? We need to shorten the distance between the technologies that have vested interests and investment in those infrastructures and shorten the distance or the supply chain between the new technologies that are coming on board, which are far more energy resourceful. The fact is there's tons, myriads of companies out there with all sorts of clever devices and clever inventions, but they can't get them to market because on one side the politics is skewed, on the other side the economics are a bit bizarre, and on the same side there's huge industrialized vested interests that want to maintain a certain system so they can maximize the profit that they've invested in a certain infrastructure. So we need to shorten the distances in time between the clever ideas that are all out there and when they come into place.
Well, if you really want answers...
Jack, have you got anything to... Jack, if you could respond to the things that Nick has said, have you got a response to that?
Yes, I think so. What we have to do is declare all the Earth's resources as a common heritage of all the world's people. You have to do away with the money system, private ownership of land, all that. And not only that, you have to make it available to people. People don't need money, and they don't need jobs. As you understand, perhaps, some of the automobile companies are installing 80% automation. And if they keep doing that, the public will not have the purchasing power to sustain the system. Therefore, it comes to an end. No system is ideal. No one can design the ideal city or the best laptop. You can only do the best laptop you know of up to now. 2 years from now, it'll be smaller, lighter, faster. It has to be a global enterprise system in order to work.
I don't think we
Jack,
have that
thank you
kind
very,
of...
very much.
I just want to mention...
sorry, please go ahead, Roxanne, and then we're going to begin to wrap up.
I'll make this short. I don't think we have that kind of time to enable the free enterprise system to evolve into a system that you're talking about. We really have to introduce a different system that is run by the benefit of science and technology for the well-being of people and the environment. We don't see any other way. We're running this system, the Earth into the ground. We have threats of nuclear war. We have threats of polluting the air, the water, and our food. And this system is not solving the problems fast enough. The other is overtaking quicker.
Roxanne, thank you very much. As we begin to wrap this up, I'd like to try and get everybody's view, because it's good to try and get some closure. It's difficult because perhaps we're making you give us a guess, but Nick, how many people do you think we can comfortably perhaps support on the planet? We're beginning to be towards the end of the show.
I think all the predictions of the number of people that we're going to have, we can fully support them. We're running out of time to do that, though. We need to get smart, and we need a big step change in the way we manage planet Earth. And some of the things Jack has said are very interesting. The other colleagues have said are very interesting. We need to decouple economic growth from resource use, and we need to start employing people not in making 50,000 iPods for everybody and 30,000 motor cars, but in managing the natural resources of this planet, which actually are the bounty and the foundation of all livelihoods.
Thank you very much, Nick. Jay, you next. What do you think is the maximum number of people we'll be able to support on Earth?
So also a difficult question for me to answer. I think talking about 9 billion or 12 billion, by 2050, that's a huge number. But I do believe that we can do a lot more with a lot less. And one of the issues that's come up, and Jack was talking about it, was the technology, and I think Nick was talking about it as well. There is a lot of technology that can be brought to bear on environmental issues and help us live sustainably. So we have a lot of work to do, but I think we need to recapture our respect for the environment, and I think that there's enough technology around to help us do that.
All right, Jay, thanks. Stephen, I want to go to you next and reiterate the calculation you came up with for us today about if everyone stood shoulder to shoulder in a big, thick, tight crowd on only Earth's land, how many people could we literally fit on the surface?
So that's 300 billion. It's a lot.
300
million.
3
million billion. I'm sorry.
3 million billion. Okay,
Yeah.
There you go. The answer is 3 million billion as calculated. But Stephen, what are your opinions on the actual number of people that we could sustain here on this planet?
Well, that's a great question. It's a very hard one. But I would say that one thing we should maybe try and do is get the population to plateau somewhere. A point that hasn't been made that I'd like to finish on is that in the West, developed countries, we don't really have a huge problem with runaway populations. We have about 2.4 kids per 2 people. It's not that bad. It's in developing countries where you've got this huge increase in population that leads to poverty. One of the most important things we should try and do is help developing countries become developed countries, and their population growth will go down, and we can maybe try and reach a population plateau.
Thanks very much, Steve. I think that brings us towards the end of our show. So thanks much to all our guests. Thank you to the hundreds of people who are commenting. Jack, if we could go to you finally. I know it's a difficult question. How many people do you think we can effectively support? I know that's a difficult question, and then we'll end the show there.
Oh, how much people do we need? Not how many people can we support. That's the question.
How many do we need, Jack?
We don't need more than 100,000 or 200,000. We don't need all the people. Very few people have made enormous contributions. I think of no contributions made by politicians.
Okay.
Thanks very much, Jack. Thank you very much, Michael, for being on the show.
Yes, thank you for having me. This has been really exciting. My first live show.
So what do you think? We've not asked you. I guess you.
I have to answer this question?
Yeah.
Okay. So first of all, the guests, thank you very much for being here, and your answers were great. The way I look at it, the more people there are on Earth, the more people there are who can potentially subscribe to Vsauce. Okay?
On Truthloader.
So I would love to find a way to investigate alternate dimensions and universes and allow the human population to be infinite, because I like people and having friends and having people to talk to. So that's kind of a cop-out answer, but I think that we had a really good discussion today.
Yeah, we did. And I think if you like this discussion, we do these every single Thursday, so hit subscribe. Thanks very much for watching. It's been a huge amount of fun. Thanks to all of our amazing guests, and we'll see you again on Thursday, live at 7 p.m. Hit subscribe, and we'll see you there.
Thank you, everyone. And, as always, thanks for watching.
Goodbye.
That's the privilege.
These bits are awesome.